All right, here we're going to evaluate the integral of x plus y plus z integrated over v, where v is the region bounded by z equals x squared plus y squared, z equals 1, and z equals 4. So we're going to do some pre-work. We're once again going to sketch this. We've already sketched one paraboloid. We're getting to be old pros at this. It's going to look kind of like that. Then we're going to have a plane at 1 and a plane at 4. So two separate planes. And a plane down here. Oh, that was wild. Okay, that was, a serviceable job of doing what I wanted to. So we have two planes kind of cutting this hyperboloid. So let's think about this problem. We eventually kind of want to do this top minus bottom thing, but you'll notice that the top minus bottom kind of changes throughout this region, if you think starting in terms of z. So if we were to start here and kind of go down, I see that my top is given by z equals 4, and the bottom is given by, in this case, the hyperboloid. But if I go here, the top is given by z equals 4, and the bottom is given by z equals 3. So we have a different top and bottom if we start thinking in terms of our z coordinates. So if we start with z, the top and bottom function changes on our region. What this tells me is that I want to start with x or y, which means I'm going to need to solve my equation here for either x or y. So let's go ahead and do that. It's not too bad. We'll get that x squared equals y squared minus z, or z minus y squared. Then we get that x equals plus or minus square root of z minus y squared. And we can tell that this means that x is between z minus y squared, square root of z minus y squared, and negative square root of z minus y squared. Okay. So we started by solving for x. So there's our, top minus bottom. What's this going to look like when we smush onto the YZ plane? Well, if I kind of, again, think of smushing it onto the YZ plane, what's it going to look like? The picture is going to look something like this. So we'll have our y, we'll have our z. We're going to have this up here at 4, this down here at 1, and it kind of looks like this. I'll do a little dot, dot, dot there. Where this is the paraboloid, z equals y squared. That's kind of the picture we have here. So when we integrate this, we're really going to have, so this is z equals y squared. Keep in mind, we don't really want to integrate in respect to z because then we have different things on the top and bottom as we move across. That was the whole problem. We want to kind of wait until the end to integrate in respect to z. So I will want to think of this as, since I want to integrate in respect to y first, we're going to have y equals, solve this for y, plus or minus square root of z. So we're going to have that y is less than or equal to square root of negative z, or is greater than or equal to negative z, and less than or equal to positive square root of z. Okay. So we did our smush, and now we've integrated, we have our inequality in respect to y. Now we're going to smush onto z, the z-axis, and see what we have left. Well, when I smush it onto the z-axis, what do we get left? Well, it's just the area from 1 to 4. So we see that negative 1 is positive 1 is less than or equal to z. It's less than or equal to 4. So there we go. We have that. And that will give us our third inequality. So when we go ahead to set up this integral, this is an awful integral, probably like just it's bad. What are you going to get? You're going to get the integral from 1 to 4 in respect to z. Then we're going to have the integral from negative square root of z. I usually work from the inside out, but I guess I didn't today. Negative square root of z to positive square root of z there. Then we're going to have negative square root of z minus y squared, and positive square root of z minus y squared. That'll be x plus y plus z. And then we, again, our inner was dx, then we went dy, and then dz. Okay, yeah, so we set up that integral, and that would allow you to calculate the integral over this region.